Personally, the Orion starship is the best use of nuclear weapons I can think of, provided the ships don't depart from very near the Earth. Project Daedalus is a recent design of the British Interplanetary Society. It assumes the existence of a nuclear fusion reactor, something much safer as well as more efficient than the existing nuclear fission power plants. We do not yet have fusion reactors. One day, quite soon, we may. Orion and Daedalus might go 10% the speed of light. So a trip to Alpha Centauri, 4.5 light years away, would take 45 years, less than a human lifetime. Such ships could not travel close enough to the speed of light for the time-slowing effects of special relativity to become important. It does not seem likely that such ships would be built before the middle of the 21st century, although we could build an Orion starship now. For voyages beyond the nearest stars, something must be added. Perhaps they could be used as multi-generation ships, so those arriving would be the remote descendants of those who had originally set out centuries before. Or perhaps some safe means of human hibernation might be found, so that the space travelers might be frozen and then thawed out when they arrive at the destination centuries later. But fast interstellar spaceflight, approaching the speed of light, is much more difficult. That's an objective not for 100 years, but for 1,000 or for 10,000. But it also is possible. A kind of interstellar ramjet has been proposed, which scoops up the hydrogen atoms which float between the stars, accelerates them into an engine, and spits them out the back. But in deep space, there is one atom for every 10 cubic centimeters of space. For the ramjet to work, it has to have a frontal scoop hundreds of kilometers across. When the ship reaches relativistic velocities, the hydrogen atoms will be moving, with respect to the interstellar spaceship, at close to the speed of light. If precautions aren't taken, the passengers will be fried by these induced cosmic rays. There's a proposed solution. A laser is used to strip electrons off the atoms and make them electrically charged while they're still some distance away. And an extremely strong magnetic field is used to deflect the charged atoms into the scoop and away from the rest of the spacecraft. This is engineering on a scale so far unprecedented on the Earth. We are talking of engines the size of small worlds. Suppose that the spacecraft is designed to accelerate at 1g, so we'd be comfortable aboard it. We'd be going closer and closer to the speed of light until the midpoint of the journey. Then the spacecraft is turned around and we decelerate at 1g to the destination. For most of the trip, the velocity would be very close to the speed of light and time would slow down enormously. By how much? Barnard's star could be reached by such a ship in 8 years ship time. The center of the Milky Way galaxy in 21 years. The Andromeda galaxy in 28 years. Of course, the people left behind on the Earth would see things somewhat differently. Instead of 21 years to the center of the galaxy, they would measure it as 30,000 years. When we got back, very few of our friends would be around to greet us. In principle, such a journey, mounting the decimal points closer and closer to the speed of light, would even permit us to circumnavigate the known universe in 56 years ship time. We would return tens of billions of years in the far future, with the Earth a charred cinder and the sun dead. relativistic spaceflight makes the universe accessible to advanced civilizations, but only to those who go on the journey, not to those who stay home. These designs are probably further from the actual interstellar spacecraft of the future than Leonardo's models are from the supersonic transports of the present. But if we do not destroy ourselves, I believe that we will one day venture to the stars. When our solar system is all explored, the planets of other stars will beckon.
Space travel and time travel are connected. To travel fast into space is to travel fast into the future.
We travel into the future, although slowly, all the time. But what about the past? Could we journey into yesterday? Many physicists think that this is fundamentally impossible, that there is no way we could build a device which would carry us backwards into time. Some say that even if we were to build such a device, it wouldn't do us much good, that we couldn't significantly affect the past. For example, suppose you traveled into the past and somehow or other prevented your own parents from meeting. Why, then you would probably never have been born, which is something of a contradiction, isn't it, since you're clearly there. Other people think that the two alternative histories have equal validity, that they're parallel threads, skeins of time, that they could exist side by side. The history in which you were never born and the history that you know all about. Perhaps time itself has many potential dimensions, despite the fact that we are condemned to experience only one of those dimensions. Now, suppose you could go back into the past and really change it by, let's say something like persuading Queen Isabella not to bankroll Christopher Columbus. Then you would have set into motion a different sequence of historical events, which those people you left behind you in our time would never get to know about. If that kind of time travel were possible, then every imaginable sequence of alternative history might in some sense really exist. Would it be possible for a time traveler to change the course of history in a major way? Well, let's think about that.
History consists, for the most part, of a complex multitude of deeply interwoven threads, biological, economic, and social forces that are not so easily unraveled. The ancient Greeks imagined the course of human events to be a kind of tapestry created by three goddesses, the Fates. Random minor events generally have no long-range consequences, but some, which occur at critical junctures, may alter the weave of history. There may be cases where profound changes can be made by relatively trivial adjustments. The further in the past such an event is, the more powerful its influence. What if our time traveler had persuaded Queen Isabella that Columbus's geography was wrong? Almost certainly some other European would have sailed west to the New World soon after. There were many inducements: the lure of the spice trade, improvements in navigation, competition among rival European powers. The discovery of America around 1500 was inevitable. Of course, then there wouldn't be any postage stamps showing Columbus, and the Republic of Colombia would have some other name. But the big picture would have turned out more or less the same.